Okay, so here we have the spool, and the things that we know about the spool are its mass, the radius from which the force is being applied, and that there is a constant downward 10 Newton force. Also not stated before, but something that is important, the starting angular velocity is going to be 0. So the question is, how long does it take to unwind 10 meters of rope? So if we start off with Newton's second law for rotation, net torque is equal to I alpha, and net torque is also equal to R times F. Looking at this equation, time is not hidden anywhere in here. We know the force, we know the radius, we can calculate the moment of inertia given the mass and the radius. The only place where you can get time from is within that alpha. You're going to need to get the value for alpha. So we're going to have to use the kinematic equations. Looking through the list of kinematic equations, the one that we'll end up using is theta equal to omega t plus 1/2 alpha t squared, where the starting omega is going to be 0. The alpha, or the theta, we can figure out based upon the length of 10 meters of rope. And we're going to get this alpha from this equation over here. So we've got to solve this equation for alpha and then bring that over to here. So, moment of inertia for a disk is 1/2 mr squared. I plug that in and I get 3.75 kilograms per meter squared. I also happen to know R and F, so I can plug that back into this equation of the I alpha equal to RF. So we get an alpha value of 1.33 radians per second squared. If you want, you can go through and plug in the units for each one of these to make sure you actually do get radians per second squared. I did that on my own, and I'm confident that this is the right number. So once I have that alpha, I can take it and bring it over to here. So I'm going to plug in the 1.33 up here. This is 0. I've got to figure out how many radians is 10 meters of rope. So in other words, if I were to lay out 10 meters of rope, how many times, what would the theta be for how many times it goes around the spool? I know the relationship between theta and the linear displacement is here. X is equal to r theta, or theta equals x over r. So 10 meters divided by 0.5 meters gives me an angular displacement of 20 radians. 20 radians. Now, what is 20 radians? To figure out 20, or how many rotations is that, if I were to do 20 divided by 2 pi, that's 3.2 or 3.18 rotations. So basically wrapping around the spool a little over 3 times, that's how many, how much 10 meters would be. But anyway, the goal here was to get 20 radians. I have theta, I have alpha, and I can plug that into my kinematic equation and solve for t. So 20 is equal to 0 plus 1/2 alpha t squared. Solve for t. T is equal to 20 divided by 0.665, which is 30.08, or t squared, I should say. And then we take the square root of both sides to get a time of 5.5 seconds. Now, what if I were to add the force of friction into this problem? The force of friction basically requires the addition of an RF. So here we have our spool, and this time, instead of assuming that the spool is resting on this like infinitesimally small rod, it's actually resting on some rod with a radius. And the torque I alpha remains the same, but this time I'm going to have to add together the R and the F. This is the R and the F, the force applied, that 10 newtons of force. And I'd have to subtract out the force of friction. This is going to reduce the amount of torque. I'm not going to go through and solve it. I'm just showing you what you would have to do if friction were present.